Well, welcome to, I think it's week 6, and today's topic is crashing your projects, and that forms the second half of your second technical question on the in-class test. It isn't actually a topic for your coursework this year. It is some years, but it isn't this year. So it's not for that, it's for the in-class test. And the topic is about making your project shorter. So it's not crashing, doesn't mean anything disastrous. It simply means making your project shorter. And that's obviously important when you present the pitch for your project and say it's going to cost this much money and take that long. What do you think the first thing the stakeholders are going to say is going to be? Can it be shorter? Can it be cheaper? And if you can make it shorter and cheaper, then you've got a better chance of your projects being adopted and put forward. So how do we crash our projects? How do we make them shorter? And how do we take account of possible costs or benefits of that? Well, normally crashing is done on a cost-benefit basis, and if you want to make tasks shorter to happen more quickly, then there can be costs associated. Not always, but there can be costs associated with making tasks happen more quickly. For example, you might have to pay overtime. You might have to buy fast-drying cement. There may be another of other things that you might have to do to make the task happen more quickly. Or, of course, if you've got some spare electricians and one electrician can do it in 4 days, just chuck on another electrician, they can do it in 2 days, and that doesn't cost you any money at all if it's feasible. So that would shorten the task at no cost if you've got the spare resources. But the benefits are more obvious, because if you shorten your project, you save on the daily overheads. That might include your salary, of course, so it's not all good news. But the benefits avoid any overheads. So every day you can shorten the project by, that's a day's overheads avoided. And we will compare the benefits received from making it shorter to the costs of making it shorter. And what we hope will happen is you'll be able to make your projects shorter and cheaper. And of course, if you can do that, you're beginning to understand why project managers get paid so much money. A shorter project that's cheaper, there's your 60 grand a year. Nothing else, just that gets you a job. Now, there are several ways in which you can shorten your project. First of all, of course, add more sources if you've got them. Use effort-driven scheduling. If one person can do it in 4 days, 2 people can do it 2 days. If that's feasible, you can do it. It doesn't cost a penny. So that's the easiest thing to do. There are other options that you might try. I've listed some of them here, and these are all free as well. But if you don't have any free options, and that can happen, then what you need to look at is this new concept we're going to look at today called the cost slope of a task. And the cost slope is the amount it costs you to reduce the duration of a task by 1 unit of time. Maybe it's a day. So how do we get it from 6 days to 5 days? From 5 days to 4 days? And how much does that cost? Now, we'll make an assumption, which is common in the industry, that you can reduce your task durations on a pro rata basis. Now, what that means is if it costs you £600 to take a task from 4 days to 2 days, then it would cost you £300 to take it from 4 days to 3 days. So, in other words, £300 a day to shorten that task. And that's called the cost slope. And you have to just find out what the cost slopes are for your tasks. You go around and talk to people and gather that information until you understand exactly what can happen. And this is often a reasonable assumption to make, and we're going to follow through an example with you showing how it works. Now, in this case, with this project, all of them have cost slopes, so none of them can be reduced free. They all cost us money to reduce the task durations. The first 3 columns are what we've seen every day up until now in the module. You've got an activity preceded by, and what I'm now calling the normal duration. So if we don't do anything special, that's how long the task will take. That's how they link together. We've got a project plan. our normal plan that we've used to this point. Now then, we've got 2 extra columns, and those we have to gather information about to find out what they are. And in this case, you can see that activity A normally takes 3 days, but actually you could reduce it right down to 1 day at a cost of £450 per day. So how much will it cost to get from 3 days to 1 day? £900, yes. Whereas activity B, 4 days to 2 days, at £300 a day. In other words, £600 to get it down to 2 days. And some tasks can only be crashed by 1 day, and it's not uncommon to find some tasks that can't be crashed at all. There aren't any here, but there are in some of the examples that you'll see later in your seminars. So there we go. That's the new information, those last 2 columns. And how we start these problems and how you'll start them on your in-class test is you do a forward and a backward pass. And show us the network diagram with the key. Remember, we always give you a mark for providing a key. And in this case, what's the critical path? BDEF, and it's going to be 12 days. And we've made BDF nice and bold with big thick arrows, so visually you can see what the critical path is on the diagram. That's what we want to see from you on the in-class test. And then we have to identify the paths, ways of getting from left to right. Well, how can you get from left to right in this diagram? ACF, ADEF, BDEF. So there are 3 routes going from left to right: the top one, the middle one, if you want to call it that, and the bottom one, which is the critical path. And I've put down here the durations. Why is that 11 days, for instance? Well, if you go A is 3, D is 2, that's 5, and E is 2 is 7, and 4 is 11. So just by adding up the durations, you get these figures here, and you can therefore see why this is the critical path, because it takes longer than any other path. And I'm going to represent that slightly differently, because it's going to be easier to keep track of what happens next. I've got all of my paths with their durations, and I've also put how long they take at the bottom corner. So B4, D2, E2, F4, and if you add them together, 6, 8, 12, that's why that's 12 days. And with this one, 3, 6, 10, that's why that's 10 days. And we'll go through gradually reducing these to make the project shorter. All right. Well, where will we start? Well, if you look at our table, which was the cheapest one? E. And how much can it be crashed by? But the key question is it a critical task? So if it wasn't a critical task, there'd be no point in crashing it. But is it a critical task? It is, isn't it? So actually, that's what we would do. Our first step would be to reduce it to 11 days. We'll just look at E down here, which is critical. B, D, E and F are critical. B is 300, D is 500, E is 100 and F is 800. So the cheapest of those, doesn't matter about the others, the cheapest on the critical path is E. So we'll spend £100 crashing E by 1 day. And that will make it reach its minimum duration. We can't crash it after that. So here we go. What we'll do now is replace, for a cost of 100, wherever we saw E2, that was in 2 places, we'll replace it with EM1, EM1. What do you think the M means? Minimum. It's a minimum. We've reached a minimum duration, and that M reminds me that I can't crash that task again. Okay? And now if we add these things up, obviously this one comes to 11 because we shortened that from E2 to E1. But this one's also shorter and it's come down from 11 to 10. This one wasn't affected, but it's not critical anyway, so it doesn't matter. So what's my critical path now then?
BDEF.
Yep. And if we look at the options, B, D, E, F, we can't crash E, so that only leaves B, D and F. So which one's cheapest?
B.
Yep. And looking at the table, B could actually be crashed by 2 days. We could reduce B down to 2. But let's just look at it for a minute. We're here now. If I made that B2, what would happen to this?
It's not critical anymore.
It would be 9, wouldn't it?
Yeah.
But what happened to these? So is there any point in taking B down to 2? No. So we'll only crash B by 1 day at this point, not by 2, because that would just make this 9, leaving those both 10, so you spent all that money for nothing. So the options, B is the cheapest at £300, but we will not crash it by 2 days, we will only crash it by 1 day, and then we'll end up with a new solution. So we spent £100 with E, and now we're going to spend £300 with B, and we'll get this solution. And now, oh dear, how do we get it down to 9 days?
You choose the one in common. F.
Have a chat to each other. How do you get it down to 9 days? Just talk to your neighbour.
Crash
So that all of them have the same.
F. Crash F because it's
F is 1, yeah, I'll give you F. It's not the only solution. I'll give you one more example, A and B at the same time.
Oh, yeah.
If I crashed A and B at the same time, that would work. What other options? Talk to your neighbour.
D and C and C.
Yep. Yep. A and B, C and D, and F, and not E. We can't crash E.
No, we can't just crash.
B, D, C.
A and not A and F. If you crash F, it crashes it anyway.
B and
A and D. Yeah. The options are A and B, A and D, though it takes 2 off the middle one. C and D. There's no point in doing F and D, because if you do F, it works. Once you crash F, you've knocked a day off of everything, because F's on every path. So there's no point in crashing F and D. You'd be spending money for nothing again. So the options are these: F, A and B, A and D, C and D. Which is cheapest?
C and D.
Yeah. So we're going to take 1 day off of C and 1 day off of D. So where we originally saw C is 3 and D is 2, we're going to change that to C is 2 and D is 1. But D, when it's gone down to 1, has reached minimum duration. So we must put D1M there. And we'll end up with this new solution. And we've got 2 M's there now. D and E are both on minimum. And they're all on 9 days still, as it happens. So how do we get it to 8? Talk to your neighbour. How do we get it to 8?
You can do A, B.
Yeah, and that's it, isn't it? Those are the only 2 options. That didn't take long. F is on every path, and A and B will work as well. But there's no point in going C, A and B, because by the time you've done A and B, you've done it. So C doesn't really get involved this time. So the 2 options, F is 800, and A and B is 750. A and B, we always pick the cheapest, and that means B will now already have been crashed by a day, so B will come down to minimum. A not yet, A can still be crashed, but B will now be at minimum. And we'll have a new solution where they're all 8 days long. What's left? How do we get it to 7? Yeah, F, really. It's the only option now. The only thing we can crash that makes sense is F. And that, of course, will cost us £800. And wherever we're seeing F4 here, we'll now put F3, 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 and end up with a solution which says this. Just check that, for instance, B can't go under 2, that's right. D can't go under 1, that's right. E can't go under 1, that's right. And F can't go under 3, that's right. So just double checking, we have reached minimum on all of those. And now how do we get it down to 6?
We can't. You can, but you will not decrease the critical part, so there's no point carrying on.
Well, if you did A and C, you'd make these shorter, but what would happen to this one?
So you just waste money.
You'd waste money. Yeah, you'd make up some slack, you'd get some slack back, but you'd waste money. And your stakeholders won't be impressed. So actually, once you have a critical path where all tasks on it are minimum, that's as low as you can go. All right? So in this case, we cannot go to 6 days. It's not feasible to do so. So, we know now this is the shortest possible duration for the project, and we know why. We also know there's no point in shortening the lengths of the other paths, and we know why. You discussed that with each other. And to add to our understanding of this, a couple of things I want to point out. Remember we crashed E for 100, then a B for 300. If you get it right, these should gradually get more expensive. So if this says 100, 200, 100, I know I've made a mistake. It must gradually get more expensive or stay the same. Otherwise you're getting it wrong. And then, suppose I tell you that the fixed daily overheads for this project are £500. So to go from 12 days to 11 cost us £100, but gained us £500. So what's happened to our total costs? 400 less. We spent £100 to reduce it from 12 days to 11, and we saved £500 in terms of overheads. So the total costs, whatever they were, are now £400 lower. So we have a 1 day shorter project that's £400 cheaper. That's good news. But then to go from 10 days, how much have we saved now? On top of the other 400 means a total reduction of 600. So whatever total costs were at 12 days, by the time you get to 10 days, that's £600 lower. Okay, but would you go down to 9 days? Yeah, it's still cheaper than it was originally, but it would then make the total cost go up a little bit. And most projects exhibit that pattern. The total cost goes down for a little while, then you run out of cheap options and it starts to go back up again. So you can find, usually, a minimum solution. And the minimum solution in this case would be 10 days. So if you wanted to do this project at its cheapest total cost, you would stop at 10 days. But sometimes, you remember the iron triangle, time, cost, specifications? Sometimes time is the most important thing. Where would you stop then? Right down to 7. Yeah? If time was the most important thing, you'd go right down to 7 days, regardless of the cost. Because on your iron triangle, cost is not the thing that's driving you, it's time. So if time is the most important thing, you go right down to 7 days. If cost is important to you, you'd only go down to 10 days. But in any case, you probably have to talk to your stakeholders to work out what would be the best solution. And that's what we'll expect you to do in your in-class test. So the 2 in-class test questions, one will be about what we did last week, which was resource management, drawing those charts. And if you've got a visual mind, those questions are fairly easy for you with a bit of practice. And the other question is going to be on the crashing. And if you have a logical mind and can keep track of what's on those tables, you'll be good at that. But certainly you should practice both. So if you struggled with last week's technique, you may find this week's technique somewhat easier. It's just the way people's minds work. Anyway, 2 types of solution, just to summarize what we said. The first one is to take it down to the shortest possible duration at the lowest possible cost. And that was the 7 days. The second possible solution is to find the minimum total cost solution, and that was to take it down to 10 days. And those options should be presented to your stakeholders for a decision as to which one is most appropriate. And it may be true that other intermediate solutions make some sense given the context of the problem that you're dealing with your particular project, with your particular contractors and your particular stakeholders. So there's no universally right answer to this. And please note, though you may be surprised by this, there's nowhere in Microsoft Project where you can put a cost slope. And there's no button you can push to make it crash your projects. So though last week it would do leveling, it does not do crashing. It's beyond the ability of a computer to run that as a simple subroutine. But you can do it yourselves, and for example, the cost unit, you could put it on your resource sheet as a unit of materials. And then every time you crash a task by a day, whack on another unit of materials. And then the costs would reflect your decisions about what happens, and you can watch your Gantt chart to see if you're actually managing to make your project happen more quickly. So though it's clumsy in Microsoft Project to crash, it's certainly possible. And you can keep track of all those costs we were looking at before. But there's nowhere where you can put the minimum duration, and there's nowhere where you can put the cost slope. So we have to improvise a bit to be able to do crashing on our computers. All right, now your turn. I'd like you to have a go at doing this, helping each other. Let's see if you can do this one. We've got time. Let's see if you can do this one during the lecture, and then we'll follow up with some more examples after the lecture. I'll just stop the recording.